Today we're going to talk about higher order polynomials, and to get you started on that, I'm going to want you to recall the polynomials that you know well. From Algebra 1, we learned linear and quadratic, and then in Algebra 2, we learned cubic. So we're looking at some polynomials here that we know well. I'm going to go ahead and add the quartic there. So there is the quartic. Looking at these functions here, if we think about them, there is a lot of characteristics that they share, and so we're going to talk about some of those characteristics because all polynomials share those characteristics. If we look at linear and cubic right here, they both have an odd exponent. When there's no exponent written, we know that's an exponent of 1, and this one's got an exponent of 3, so both of them have an odd exponent. They both start on the left and end on the right. Start on the bottom here on the left, end at the top right. That is going to be true for every polynomial that has an highest exponent that is odd. The ones with the even 2 and 4, if you look at those, they both start at the left top and end at the right top. That is going to be true for every polynomial that has the highest exponent as an even number. Now, that's not the same thing as an even or odd function. It is the same thing as the exponent only. So we're only looking at that part of it. So let's talk about what those end behaviors look like. So polynomials, the degree of the function is the highest exponent of the polynomial, and that degree gives us a lot of information. We talked about it giving us the end behavior. So an odd degree would be a polynomial like x, or x to the third, or x to the fifth, or x to the seventh, and so on. The highest exponent has to be odd. There are two possibilities for the end behavior there. You always want to go back and think about the line because that's the one that you know well. And so a line with a positive slope looks like this, and a line with a negative slope looks like this. So for an odd degree polynomial with the coefficient that's positive is going to start at the bottom and end at the top. So we write that as x approaches negative infinity, y is approaching negative infinity. So this means on the left, because that's where x gets smaller, y is also getting smaller, so ending at the bottom. And then as x approaches positive infinity, so the right, y is also approaching positive infinity. So on the right, because that's where x gets bigger, y is also getting bigger because it's getting bigger on top. And then this one would be the opposite. As x approaches negative infinity, so on the left, y is approaching positive infinity because it is going up on that left side. And then as x approaches positive infinity, so on the right, y is approaching negative infinity, so down on the bottom here. For the even degree function, so we're talking about an x squared, an x to the fourth, an x to the sixth, and so on. That you're going to go back and revert to the quadratic because you know that one well. And so our quadratic, when we had a coefficient that was positive, opened upward. When we had a coefficient that was negative, it opened downward. So we say as x approaches negative infinity, y approaches positive infinity here. Because on the left, it's going up. And on the right, as x approaches positive infinity, y is also approaching positive infinity. So on the right, it's also going up. Notice these two are doing exactly the same thing. These are doing the opposites, and these are doing the same. So as x approaches negative infinity here, y is approaching negative infinity. And as x approaches positive infinity, y is also approaching negative infinity. So down, down. Those are your four possibilities of end behavior for polynomials. You're going to look at the term with the highest exponent. You're going to check to see if it's even or odd. And then you're going to look at its coefficient right in front. If it is positive, then these are our end behaviors. If it is negative, these are our end behaviors. And always revert back to the ones that you know, the linear one and the quadratic one, because they all work the same. Now let's talk about some more characteristics that we have for our polynomials. We talked about the end behavior, which is the behavior of the y value, or AKA if x as x approaches on the left negative infinity and on the right positive infinity. We're going to talk about other characteristics of polynomials now. If you notice these polynomials, they are smooth curves. With no sharp edges. And they're continuous. They have no gaps, holes, asymptotes. So if we talked about an absolute value function, that one we know is not a polynomial because it's that V shape. It's got that sharp edge on the bottom. If we talked about the rational, we know that's not a polynomial because it's got an asymptote. So you want to look at those on the graph. It's a smooth curve, it's continuous, it does not have holes, it doesn't have asymptotes or anything of the sort. All right, on the bottom here it shows you the definition on the standard form. Sorry about that, that's a little blurry, let me fix it. All right, so here is our polynomial, and that looks kind of confusing, so I'm just going to write another one out to the side so you can see what that looks like. That's what a polynomial looks like in standard form. It's got them all listed out in order on the exponent. Sometimes they're not in order. You want to make sure you're looking for the one with the biggest exponent. So when we talk about end behavior, we're talking about this right here, 5x to the 4th power. We're not looking at these because those are the ones with the smaller exponent. We're looking for the one with the biggest exponent. So this would be even, and then this would be positive because there's no sign in front of it. So that would be, so the degree is the highest exponent. The degree also gives us other information about the polynomial. It gives us the total possible roots or zeros or x-intercepts. So our degree equals max roots. So if we have a polynomial that is to a degree of 9, it can have 9 roots. If we have a polynomial that's a degree 7, it can have 7 roots. That's the maximum number of roots. And it can be a combination of imaginary roots and real roots. Now for a maximum number of minimums or maximums, and that's talking about relative ones and absolute ones, or AKA the terns. How many terns can that polynomial have? It is the degree minus 1. So if it is a 7th degree polynomial, it can have 6 terns or 6 relative max and mins. All right, so looking at these polynomials right here, it will give us a lot of information. If I look at that highest degree term, so in this case, the highest degree term is this one right here, negative 3x cubed. The degree is 3. That means that there are a maximum of 3 roots, because we said that's how many solutions it can have, is whatever that highest degree is. Now for our left and right end behavior, that is an odd exponent and it has a negative coefficient. So this is like a line with a negative slope, which would make it like this. It starts at the top and ends at the bottom. So on the left, y is approaching positive infinity. On the right, y is approaching negative infinity. That would be our end behavior. You go ahead and try 2 and then we'll check it. That's what you should have gotten. 4 is the degree there. It is just like a quadratic, so it's going up and up. So y is approaching infinity and y is approaching infinity. All right, on top of the degree, there is also a multiplicity on the roots, and that's the number of times that a factor appears. And in this case, it must be in the factored form, not that standard form. But if we saw something like this, x plus 4 to the 2nd power, the multiplicity is 2. X plus 4 appears twice as a root. That's what that multiplicity means. That tells us kind of what's going on in the middle. So end behavior tells us what's going on at the very ends of the polynomial. This multiplicity is going to tell us what's going on in the middle of the polynomial. If the factor has a multiplicity of 1, then it's going to be a regular 0 where it crosses the x-axis. So that would look like x minus 2. You've seen that quite a bit. If the multiplicity is even, that means something like x minus 2 squared. My multiplicity, which is the exponent on the factor itself, is even. It is going to touch at that point and stay on the same side of the x-axis. It does not cross. And then if we have an odd multiplicity, like x minus 2 cubed, it is going to have this point of inflection. So it looks like it's coming up in one direction and then it kind of switches as it continues to increase. That's called a point of inflection. In Algebra 2, you may have heard it be called wiggle because we didn't use the proper vocab there. In pre-cal, we really want to make sure we use the proper vocab. So that's a point of inflection. We have abbreviated that as POI. All right, we're going to use all of that information to sketch our graphs now. So here are some examples we're going to run through. On this first one, this is given to you in the factor form. If they give it to you in a factor form, they're doing you a favor because that way you can take more information from it. But to figure out the highest degree term, you're going to have to think through that factored form. If we multiplied all of this out, that would give us our highest degree term. So coming out of this parentheses, it would just be an x since there's no exponent. If I FOILed this out, I would end up with an x squared as my highest term. And if I multiplied x minus 4 times x minus 4 times x minus 4, because that's cubed, I would get an x cubed. And then when I multiplied these together, remember when you're multiplying these, you keep the base and add the exponent. So I would get x to the 6th power. That is going to be my term of highest degree. So my degree is 6. You could multiply all of that out. You would end up with that x to the 6 and the rest of the equation in standard form. But really the only part I need from the standard form is that highest degree term. So all I did was just try and figure out what is going to be the highest degree term so I can find the degree. It is even, and this term is positive right here. So my end behavior is going to be like the quadratic. Y is going to approach infinity on both of those. Now, our roots come from this factored part. Remember from Algebra 1, that is x minus r1, x minus r2, x minus r3. When it's in the factored form, it's always x minus your root, x minus your root. So my root in this first one is going to be -2. Now, to figure out what happens at -2, I look at the exponent on that factor. There's none written there, so I know it's a 1. We said when that factor has an exponent of 1, it is going to cross there. So in this case, it is going to cross at -2. My next factor has x minus 1. The root there would be 1. It has an exponent of 2. We said when the exponent is even on that factor, then it is going to be tangent. So at 1, it is going to be tangent. And then my third root is coming from this factor. 4 minus 4 is what would make that 0. That exponent is 3. That is an odd number. So that's going to be our POI. So this example here has all 3 of them, which is great. First thing I would do is plot my roots. So I've got a point at -2, a point at 1, and a point at 4. Now for our end behavior, I'm just going to draw that off to the side a little bit. It says it's going to be up and up, so I know that it's going to be right there and right there. That's what's going to cause it to be up and up at the end behavior. Now we're ready to do what's in the middle. So I start at the top. At -2, it says I'm going to cross. So I'm going to cross at -2 from the top to the bottom. At 1, it says it's going to be tangent. So I am going to touch that point and remain on the same side of the x-axis. And then at 4, it says the POI, and so that's the one that kind of looks like a wiggle there, and it keeps going up. So there is my graph. When we are grading these, we are not going to be checking to see how far up or how far down you go. We are going to check that the end behavior is correct, the roots are in the correct location and what's happening at the root is correct. So it is a cross right here, it's a tangent right there, and it is a POI right there. This right here is a relative max. And then these two are either absolute mins or relative mins. This can have an absolute because it is going up on the top, so one of those is going to be the absolute lowest point, or both of them can be. Now, that would occur, we're not going to ask where it is on the y. We could ask where it is on the x. It would be in the middle of these 2 points. So we've got 1, 2, 3 units. So at 1.5 units in either direction, that's where it would be. And so in this case, that would be at -1/2. And so we could say x equals -1/2. So that's the way we do it if it's factored. We need to talk about what happens when it's not factored now. So here we have y equals 2x to the 4th minus 2x squared. You got to factor it. At this point, everyone should know how to factor. So we're looking for our greatest common factor here, which in this case is 2x squared. 2x squared times x squared would give me that 2x to the 4th, and 2x squared minus 1 would give me this second term. Now you should recognize that as the difference of 2 squares. So that factors to be x plus 1, x minus 1. That's what we can use now to pull up our information and graph. This is what I would use for the degree though, because we need that highest exponent. So in this case, the degree is 4. It is positive, so y is going to approach infinity and y is going to approach infinity on both sides. For our roots, this one right here would be our first root. That's the one most people miss. That's 0. We could write x minus 0 squared, but people don't usually write that. So it's just x squared, so the root there is 0. Then we've got 1 at -1, and then we've got 1 at +1. The 0 has a 2 on it, so it is going to be tangent there. Both of these have an exponent of 1 since nothing's written there, so both of these are going to cross. So 0, -1, 1. My end behavior is up and up, so I'm going to start at the top and cross. I'm going to be tangent at 0. I'm going to cross at 1. And so there is our polynomial. Again, these are absolute minimums because they are the lowest point on that graph. This is a relative max because it is the highest point at that particular section. We'll factor one more just to practice that part of it. Our greatest common factor here is 3x. You should always be taking out the greatest common factor first. That leaves us with x squared minus 2x minus 8. You should recognize this trinomial as being able to factor as well. And so we go into the next part there, x times x. Then we're looking for what multiplies to be -8 and adds to be -2. And that is a -4 and a +2. Our roots there would be 0, 4, and -2. And they would cross at all 3 places. Since there's no exponent written, it is a 1. Again, for the degree, you would take that one right there. So 3 would be our degree there. This is positive. So on the left, it's going to be coming from -infinity. On the right, it is going to be coming from +infinity because that's just like a line with a positive slope. So we've got 0, 4, -2. We're going to cross at all 3 places since those all have 1. You can't see that, sorry about that. So we're going to start from the bottom, cross, 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 and there is our polynomial. This has a relative max and a relative min. It does not have an absolute because it goes on forever up and down. So there's our characteristics of polynomials and graphing them.